In the previous video, as I am discussing the commands of the beat frequency program which I have to be given in the MATLAB, a script file. So I am discussing the sound, that how we can produce the sound of the beat frequency in the MATLAB. We can easily produce the sound of the beat frequency in the MATLAB as simply given the command sound s, fs. This s comes from this formula, right? And this fs is basically the frequency, as we have assigning this frequency, and we can also change this frequency fs with f1 and f2, and also here and also we write it here f1 f2. When we change our frequency with fs from f1 and f2, then our beat frequency sound is also be change. And when the sound is to be produced in the MATLAB, then it is a necessary condition that how this sound is to be stored in the MATLAB. Then for this condition, we have to be written a command which is pos d plus 0.5. D is basically the distance which is covered by the wave, as we have already assigned the value of the d in our program, and 0.5 is basically this selected time, this limited time during which the wave is completed its cycle. Then when the wave is completed its cycle, automatically then the sound which is to be produced by the resultant wave would automatically be stopped. Now let's come another to my slide. In this slide, I basically inserted my program which I am to be run in the MATLAB. As you can see that first command I am given clear all, close all CLC now to remove the temporary variable in the computer memory, and then I assigning the values of the frequencies f1, f2, fs, and then I assign the value of t, and then we can calculate the peak value or amplitudes of the wave, and then we can calculate the time t of the wave, that during which time the wave is completed its cycle, and then I given the value s, which is basically comes from the principle of the superposition in the beat phenomena. And then I am given the command of sound in order to produce the sound in MATLAB, and then I given the command pause in order to stop that sound. Now let's comes to another slide. In this slide, I basically inserted a video in which I already myself discussed that how this sound is to be produced in the MATLAB, and by changing the frequencies fs with f1 with f2, how what type of sound is to be produced in the MATLAB. So from this video, you can understand it betterly. In this video, as you can see that I have written this program which is basically producing the sound of beats in MATLAB. Now I have given the command s, fs in the first case, so it produces the sounds of the beats. Now I have basically run the beats and you can hear the sound. Now when I change my frequency command with f1, then its sound is also changed. So when I run the speed program, you can hear this sound. In this sound, as you notice that at some parts of the sound the voice is louder, and at some parts of the sound the voice is smaller because of the interference of the two waves, right? Because of the interference of the two waves, because at some parts the constructive interference is performed and at some part the destructive interference is performed, so that's why the louder and the smaller notes you can hear. When I change my frequency command with f2, then you can hear this frequency sound. Because these two frequency sounds are similar, because I have given a very small difference in between these two frequency sounds, so that's why in most of the parts, as you can see, the louder note.